This slide introduces the three major learning types in machine learning. Many candidates mix them up, so let's make it simple. Supervised learning means the model learns from labeled examples, just like a teacher showing the right answers. Unsupervised learning has no labels. The model looks for natural patterns on its own. Reinforcement learning is learning by doing. The agent tries actions, receives rewards, and improves through experience. A strong interview answer is: supervised uses labels. Unsupervised finds structure. Reinforcement learning learns behavior through trial and error. A real example is a smart assistant. Supervised models classify speech. Unsupervised models group user behavior. Reinforcement learning improves action choices. Interviewers may ask, when do labels matter? Why does clustering help? How does an oral agent explore? Short answers: labels guide prediction. Clustering reveals groups. Exploration helps find better strategies. Here we go deeper into supervised learning. Think of it as pattern learning from clear examples. The model receives input and the correct output, learns the mapping, and predicts new labels. A clean interview answer is: supervised learning uses labeled data to solve classification or regression tasks. This works because known outputs let the model learn precise relationships. A real example is email spam detection. The model sees many labeled emails and learns what spam looks like. Supervised learning powers price prediction, medical diagnosis, quality scoring, and many everyday ML systems. Interviewers may ask, what is the difference between classification and regression? Why is label quality important? How do you prevent overfitting? Clear answers: classification predicts categories. Regression predicts numbers. Good labels improve accuracy. Overfitting requires validation and re-equalization. This slide shows unsupervised learning. There are no labels. The model explores the data and discovers structure on its own. You can think of it like grouping items in a messy room without instructions. A solid interview answer is: unsupervised learning finds natural patterns, groups, and compressed representations in unlabeled data. This works because real-world data is often unlabeled, and unsupervised methods uncover hidden insights. A practical example is customer segmentation. The model groups users based on behavior without being told what the groups are. Unsupervised learning appears in clustering, anomaly detection, document grouping, and dimensionality reduction. Interviewers may ask, how does clustering decide groups? When do we use dimensionality reduction? What signals define anomalies? Simple answers: groups form through similarity. Dimensionality reduction simplifies data. Anomalies are points that differ strongly from expected patterns. Now we move to reinforcement learning. This style of learning is all about experience. The agent takes an action, the environment responds, and rewards guide better behavior. A strong interview answer is: reinforcement learning learns optimal actions by maximizing long-term reward. This matters because many decisions cannot be solved with static data. The model must learn through interaction. A real example is game playing. Systems like AlphaGo learn winning strategies by trying thousands of actions and learning from rewards. Reinforcement learning also guides robots and autonomous vehicles, where every action affects the next moment. Interviewers may ask, what is an agent? What is the environment? Why does reward design matter? Short answers: the agent is the learner. The environment is the world it interacts with. Rewards shape the behavior you want. This final slide brings everything together. Supervised learning uses labeled data for prediction tasks. Unsupervised learning uncovers structure in unlabeled data. Reinforcement learning learns behavior through rewards. A clean interview answer is: supervised predicts outcomes. Unsupervised finds patterns. Reinforcement learning chooses actions for long-term reward. These three methods cover most ML problems and guide how you choose the right tool. Interviewers may ask, when would you choose each approach? What are the trade-offs in data needs? Can you combine methods? How do you evaluate each one? Clear answers. Use supervised when labels exist. Use unsupervised when exploring data. Use reinforcement learning when actions affect future outcomes. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.